So I welcome you everyone to this another lecture of machine learning series. So today what we are gonna cover is supervised and unsupervised learning, basically the types of machine learning. So before we start, we'll be trying to see what actually is machine learning. And so machine learning is a subset of AI that enables systems to learn from data and make decisions with minimal human intervention, right? So basically, the main idea of machine learning is we are gonna give some set of data. Some data we are going to give to machine learning. We are going to train the machine learning model on some data set, which will contain, suppose, one student studying all night will get 80% marks. One student studying 18 hours in a day will get, suppose, gets some 95% marks. And one student studying only 5 hours but smartly will get 98% marks. So, suppose in this data we have to train a model, and further we have to predict it, and we have to see how much the prediction is correct. Then we'll be giving some we'll be saying that suppose the student studies 7 hours a day, and give the timing or something, 5 hours in the morning and 2 hours in the night, and what is the projected score that the students it is prone to get in his examination. So that is something which our model will be able to predict, and that we have to compare from the actual dataset, given dataset, and then we'll be seeing the accuracy of the dataset with that residual analysis. Now, in types of machine learning, we're going to include three types of machine learning here: supervised, unsupervised, and reinforcement learning. Before we start with the types, I would like to introduce you to the datasets, which are the um, one of the most important parts of machine learning. We'll be working with it at every single step. It's the core of something you can say. Without it, we can't train a model. Basically, this is something we use, and multiple types of datasets, image datasets, or you can say numerical values in datasets. And basically, we have to study labeled and unlabeled datasets that we are going to use. Labeled we will use in supervised learning, and unlabeled in unsupervised learning. So label dataset is something which contains input features along with the correct output label. So basically 1, 2, 3, 4. These four are outlook, temperature, humidity, and wind are input attributes or input features. And then we have to see play tennis as output, right? Out of these four features, we have to predict whether someone is gonna play tennis or not. As per this dataset, a person is gonna play the tennis or not. Okay. Here, wind, humidity, temperature, outlook are input attributes or input features. Play tennis is a label or output attribute or output feature. So, suppose sunny, hot, high, weak. These are the set we have to get right. If we give this thing in our model, it should give no, right? It should give no as play tennis. No, if the person is not going to play tennis in these conditions of outlook, temperature, humidity, and wind. Now, if we give something overcast, and hot, cool, mild, overcast, mild, normal, weak, right? But this pattern is not there, right, in this. So that will probably become a noise for this, for our dataset. That we'll see further. So basically, a label dataset is something which has input attributes as well as output attributes. So input will cause something to output attribute. Input will be dependent on output attribute. This pattern needs to be captured by our model, and thus our model will be able to predict the output attribute. That is something we are gonna do in supervised learning. Now, unlabeled dataset. Here, we don't have any output attribute. We have only three features, right? Age, income, spending, score, and that with that only we can do what? Clustering. Clustering means we have to group a particular number of customers here who have who are under age 25 and who have income under 40K, or suppose under 35 age, uh, for 25 to 35 age, and under 40 to 65, in this range they have income. Like that we can cluster the customers, that's it, with some particular certain spending score and all. That is called clustering. That is unsupervised machine learning. Now we are going to see supervised, unsupervised, and reinforcement learning. So basically, I have tabulated all the things so that we can capture every single thing at a time. So the first one we are going to see is what actually is supervised learning, unsupervised, and reinforcement learning. So supervised learning, as I told you, it learns from labeled data. Unsupervised learning learns from unlabeled data. Labeled data means it has input as well as output attributes, and it doesn't have any unlabeled data set doesn't have any output attribute. And here, reinforcement learning is, suppose you are someone, right, who performs some activity on getting some reward. So here we have some machine, suppose, and we give something to machine input, and it gives some output. And with that output, how much are we satisfied? We'll give some feedback that this is some happy or sad, good or bad, plus or minus. So if with respect to that feedback, again the machine is going to improve its performance every single time. So the machine is basically expecting our feedback. That is something reinforcement learning. So once again, reinforcement learning, we are going to have some system. That system will perform something, and we will give the feedback to the system. And again, the with respect to the feedback, the machine will improve its performance, or it will amend its performance every single time we give the feedback. Now, the goal of supervised learning is to predict outcomes. As we know that we have label data, right? So we have output feature also. That is label we have, right? So basically, we have to predict the outcomes only. But here we are doing clustering, right? So we have to discover the pattern out of unlabeled data set. That is how we are going to cluster the customers, and we are going to see and observe the patterns in unlabeled data set only. And here we have to maximize the cumulative reward, right? I told you that the machine or the system is accepting our um, feedback, right? If the feedback is positive or negative, that feedback we call as reward. That is something we call as reward, right? So every time positive feedback is something expected by the system, right? If we give negative feedback, it will improve itself. Some type of feedback we will give, positive, negative, something. It will every time it will improve its performance or amend its performance or modify its performance with respect to the feedback we have given to it. So its main motive is to maximize that reward. Reward means it wants a maximum positive feedback from our side. That's it. Now here we are using labeled data set, right? We know unlabeled data set in supervised learning, unsupervised learning, and here in reinforcement learning, we have environmental states, actions, and rewards. The system performs some actions, and we are gonna give some feedback, and this environment states we have, right? Now discrete or continuous predictions we have, right? In regression and supervised learning, we have regression and classification. Here we have clusters and associations. Basically, we are going to cluster a group of points, and we are going to capture the pattern out of this unlabeled data set only. And here we have optimal actions or policies. Policies is very important. Now, in learning signals, here we have loss or error function. Basically, it has a loss or cost function. Loss function is something which is the residual only. We can suppose it's proportional to the residual only. Residual means something output we are getting, and something the actual output minus predicted output, and that is proportional to that is something which the loss function is proportional to, and the average of the loss function, that net loss function, is something we call as cost function. And here we have distance metrics, and here we have reward or punishment feedback. Positive feedback means reward, and negative feedback means punishment. Here we basically some examples we include as email spam detection, stock price prediction. Here customer segmentation, market based analysis. That's all. That is something we have to capture out of the data set. And here game playing, robot control, uh, right, that one game we had where we had some uh, obstructions coming, some tables coming out of from the top in video games, and we had to shoot everything, every obstruction coming in the front of us. Then we'll move forward. That game is something which is one of the applications of reinforcement learning, RL. Now in supervised learning, we are gonna learn linear regression, the most basic algorithm for vector machines, SVM, k nearest neighbors. And here we have uh, K means clustering and DB scan and principal component analysis and a priori. Here we have Q learning, deep Q networks, SARSA, and all. every single thing we'll be covering. This is not all. Like supervised learning contains much more than this. This is just very common algorithms. We are gonna like most basic algorithms I have taken as an example. That's it. So we are gonna cover some 10 algorithms in supervised learning, and like we will try to maximize the number of algorithms we'll be learning along with the new machine learning algorithms. New machine learning algorithms which are now only introduced and which are very much effective than the existing algorithms. That is something we are going to learn also. And here these are also very like most basic things, and these three are very much important: reinforcement learning algorithms. And here now, what is the feedback type? Direct supervision. And here no feedback is there, right? Direct supervision means it's just gonna give some output, like label data set we have. So we are just expecting some value in the label, right? We're gonna give some conditions and output we have to say something. Here we don't have any feedback because we don't have label data set. We have unlabeled data set, right? We don't have any label in that. Now it has a delayed feedback through rewards. Every time we have to give some feedback and it will perform some action. And this is a reward feedback, and like feedback something we are giving as a reward, and it will amend every time its actions. So that is the system which is going to follow in reinforcement learning. Now we're going to see some common algorithms we are in each of the types of machine learning. So for the supervised machine learning, we're going to see linear regression, logistic regression, support of the machines, decision trees, k-nearest neighbors, neural networks, and many more. Like as I told you, right, we'll be seeing new machine learning algorithms also. In unsupervised machine learning, we have k-means clustering, hierarchy clustering, DB scan, principal components analysis, a priori, and eclat, and many more. And same way, we have reinforcement learning, and it's the last part of our course. So basically, we'll be learning Q learning, one of the most easiest algorithm, and it's very important. And we'll be doing Markov's learning process also, and Markov's algorithm and all, and SARS policy gradient methods. Very interesting. Now we have to. I think we should be knowing some of the most commonly used datasets in machine learning. So the first one is Fisher-Irish dataset. Irish dataset we call it. Now it is a multi-large dataset. Basically, it has to classify like iris flowers into species. We have Setosa, Virginica, and we have some attributes like sepal length, sepal width, petal widths, and that these are the attributes. That's all. Now this is something we are gonna use in unsupervised machine learning, and based on this sepal length, sepal widths, petal length, petal widths of flowers, Setosa, Virginica, versicolor, three types of flowers are there. So we have to predict which type of flower, which iris flower is this. So that is something. So basically, we are expecting some output of the out of this, right? Based on some feature, we are expecting the type of flower, classification of the iris flowers. So that's why it is a labeled dataset, and we are going to use it in supervised machine learning. Same way, we have many more labeled and unlabeled datasets. And for reinforcement learning, we are going to use OpenAI Gym. This is very important. It's basically a simulation dataset, and here we have uh, one more Atari games also ALA, that's very famous, and Mojo Code. So basically, these are one of the most common data sets we are going to use in training our models and testing our models. That's all. So basically, we'll be starting with Iris for our simple linear regression, and we'll be covering the next plan of mine is we'll be doing this linear regression in one shot, in a single shot, and further on, we'll be moving along with doing every single algorithm in single shot, in one shot, and we'll be practicing along with uh, using scikit-learn, TensorFlow, and PyTorch. Scikit-learn will be starting with for linear regression, and further on, we'll be diving into after completion of every supervised and supervised learning. And supervised, we'll be doing some neural networks, and there we'll be using TensorFlow, and along with that we'll be using, so don't need to learn separately these libraries. So that's all for today. So thank you very much for this. Next lecture is gonna be on linear regression in one shot, single shot. We'll be covering every single mathematical intuitions, concepts, and we'll be solving some problems in gate point of views, and with some AI core examinations, in colleges. And along with that, we'll be implementing every single algorithm using some Python libraries, scikit-learn, TensorFlow, PyTorch. That's all. So thank you very much.